Somewhere on the edge of most cities, or increasingly beneath them, sits a windowless building full of servers, cooling equipment, and not much else. These are data centers, and they've quietly become as essential to a functioning city as its power grid or water system. Building operations, transportation networks, and industrial processes all lean on them to run efficiently. What's pushing that reliance into overdrive right now is AI, which needs enormous computing power to do anything at all. But the story here isn't really about AI. It's about the physical infrastructure straining to keep up with it, and the strange places that infrastructure is starting to move to. The scale of a single data center's power use is easy to underestimate. A single data center can use as much electricity as thousands of households combined. Data centers currently account for roughly 2% of global electricity consumption. That figure could climb up to 4% by 2030. Right now, two main types of data centers exist. Large facilities sit outside urban areas where land is cheap and space is abundant. Smaller ones sit inside cities, built to serve local demand quickly, since being physically close cuts down on the time it takes for that data to travel. Both types share the same problem: heat. Data centers generate enormous amounts of it, and on the surface, that heat mostly just rises into the atmosphere, feeding urban heat islands. But that heat doesn't have to go to waste. In Stockholm, a district heating network captures enough heat from local data centers to warm up to 30,000 apartments a year. In Mansala, a data center has been heating the town for about a decade. Microsoft's newest cluster near Espoo is projected to eventually warm up to 100,000 homes, potentially the largest heat recovery project of its kind anywhere in the world. Similar projects are running in Denmark, where Microsoft and Meta facilities feed excess heat into local district heating systems. The catch is that this only works with closed-loop systems, setups where the water or fluid that is absorbing the heat from the servers stays inside a sealed loop so that the heat can be captured and piped elsewhere instead of just being vented into the air. And so far, this feedback is mostly a Nordic and European practice. The United States, despite having more data centers than anywhere else in the world, lags behind on adopting it. Recovering heat is one motivation for rethinking where data centers sit, but security is another, and it's pushing some facilities underground entirely. As the world feels less stable, governments and companies are relocating data into hardened, secure locations, including former nuclear bunkers. The logic is straightforward. If you lose your data, you've effectively lost the institution or company that depended on it. That fear isn't new. Science fiction books and movies have been circling it for decades. Blade Runner 2049, the TV series Mr. Robot, and Enki Bilal's graphic novel Bug all revolve around massive data erasure events that send society into collapse. Archivists have voiced a real-world version of that same worry since the 1990s, warning of what's sometimes called the digital dark age, a future where digitized knowledge becomes unreadable simply because the technology used to store it has become obsolete. Normally, data centers guard against disaster through redundancy, replicating information across multiple facilities in different global locations. Bunkers serve a different purpose. They are built to keep running through any disruption, natural or man-made, because organizations like banks, government agencies, and media companies need uninterrupted access to their data every second of the day. What used to be cold storage is increasingly becoming active storage, holding data that is in constant use. A few companies show what this looks like in practice. Data Vault operates inside a bunker the UK's Ministry of Defence built in the 1950s, repurposed for data storage once the Cold War ended. Mount 10 runs a similar facility in Switzerland. In the United States, Iron Mountain, once known for storing physical records, now runs an underground campus in Boyers, Pennsylvania, more than 200 feet below the surface. None of this is new instinct. Fear of nuclear war during the Cold War created an entire market for bunkered storage, with private companies building facilities to protect whatever a client considered irreplaceable. Bank records, federal documents, blueprints, patents, formulas, deeds, artwork, and media. One well-known example, an original print of The Wizard of Oz, is preserved underground. That same impulse produced the Arctic World Archive, modeled on the Global Seed Vault. Both are sometimes called Doomsday Vaults, built for scenarios most people would rather not think about. Underground storage isn't limited to purpose-built bunkers either. Companies like Bluebird are building data centers inside limestone mines using natural rock formations instead of constructing shelters from scratch. There's a practical case for going underground too, separate from security. Location and energy efficiency matter enormously for these facilities, and going underground offers real advantages, such as better concealment, lower energy consumption, and stronger resistance to outside interference. China has already built large tunnel-type underground data centers, treating the approach as a proven method rather than an experiment. Those advantages mentioned, such as better concealment, come with a real engineering cost. Moving heat out of a sealed underground space takes deliberate engineering, usually shafts drilled straight up or out, rather than the passive venting a surface building gets for free. But these are solvable design problems, not dead ends, and they are exactly what makes the idea of folding data centers into a city's underground infrastructure, alongside subways, utility tunnels, and district heating pipes, such a compelling direction. The challenge isn't whether it can work, but how well cities engineer and implement it. All of this is happening as the stakes of losing data keeps rising. AI systems don't just store information anymore, they act on it, they make decisions with it, and increasingly do so with less human oversight at each step. Losing or corrupting that data isn't just an inconvenience, it can mean decisions made at scale on information no one can trust. That's raised the pressure on organizations and governments to treat data resilience as a continuous physical problem, not just a software one. Going underground is one answer to that pressure, even if it's not the only one. Given how much power AI demands and how much organizations now have riding on that data behind it, underground data centers look less like a niche trend and more like where a meaningful slice of this infrastructure is heading. In the distant future, it wouldn't be too odd to see sprawling cities of data centers underground.